Today we'll be showing you how to conduct a two-proportion C-test. The first question we were given was, there has been a debate among doctors over whether surgery can prolong life among men suffering from prostate cancer, a type of cancer that typically develops and spreads very slowly. In the summer of 2003, the New England Journal of Medicine published results of some Scandinavian research. Men diagnosed with prostate cancer were randomly assigned to either go under surgery or not. The first study conducted was of 347 men diagnosed who had surgery. Of this, 16 eventually died. The other study that was conducted was of 348 men, of which of these 31 did not go into surgery. The first question was, is either an experiment or an observational study? The answer is, it was an experiment because they were randomly assigned. First, in order to come up with a two-proportion t-test, we first have to do a two-proportion interval test. First, we'll be doing staging, which is we're estimating a true difference in rates of death at a 95% confidence interval. Then we're going to go ahead and do implant, which is the randomly assigned. Then it's the 10%, which was 347 and 348 men. And yes, this is lower than 10% of all men. Then the second will be large counts, which were surgery and no surgery, which were 16 that died out of 331 and 31 that died out of 317 that did not go under surgery. And we can assume that since all conditions were met, we will create a two-prop C interval test. The following we'll be doing with a calculator, which will be a two-prop interval, which your first value will be 16, then 31, then will be 347 and 348, with a confidence level of 0.95. At the end, we can conclude that we are 95% confident that the interval of negative 0.820, which is what we got here, which is independent, because they are both independent, captures the true difference in rates of each surgery conducted of all men. Now, after we gather all this information, we're gonna now go ahead and do a two-proportion C-test. Here's the following formula for a two-proportion C-test. The hull will be the P1 and P2, zero value, and the hull will be P1 and P2 equals zero value. And we'll be using these two numbers at the end. The two-proportion C-test. The question will be, is there evidence that the surgery may prevent death? We're going to state, let P1 equal the death rate of surgery with surgery, and let P2 the death without surgery. The hull will be the death rate with surgery equals the death without surgery. And the hull will be P equals less than the death rate with surgery is less than without. Now we're gonna go ahead and plan and refer to the two-prop interval test, which was the first study we conducted over here. This information, we're gonna use it over here, and says, and since all conditions were met, we will conduct a two-prop C-test. We'll be using a calculator to conduct the two-prop C-test, which is x1 16 and x2 31, which is what we did in the first step, but now using a test statistic. After we have put everything in the calculator, our conclusion is, since our p-value of 0.0120 is less than alpha of 0.05, we reject HO. There is evidence that death rate with surgery is less than death rate without surgery. We can infer that surgery might be effective in this case. For the second example, we'll be showing you how to do a two-sample T interval. The following example is, here are the saturated fat content in grams for several pizzas sold by two national chains. We have Domino's Pizza and Papa John's. The first question is, we want to know if Domino's has a significantly higher mean saturated content than significantly higher rate means saturated fat content per pizza. Okay, for the first step, we'll be doing staging, and we're gonna let MI be the true mean of fat saturated at Domino's Pizza, which is this, and then let M2 the true saturated fat for Papa John's Pizza. We will now conduct a two-sample t-test. The two-sample t-test will be using this information right here. This will be our formula. For the calculator you use, it's going to be stat, test, and then 0-2 sample interval. And then we're going to go ahead and put in the data, and the stats, and the conditions. After we have done this, we'll be stating, and we're stating it's different in the fat content of pizza sold by two chains. This is the information we've gathered from the calculator. And now, since all conditions have been met, we can conduct a two-sample interval test. To do, we're going to do a two-sample interval test. For Domino's, it's going to be L1, and for Papa John's, it's going to be L2. And the confidence interval is going to be 90. So we're going to go ahead and put this 2. And the next question is going to be create a 90% confidence interval for the different in fat contents in pizza by the 2 change. And this is the information we gathered. And after this, we can conclude that we are 90% confident that the interval 3.0614 to 6.3719 captures the true difference in for content in pizza sold by the 2 change. Lastly, we can conclude that since our p-value of the isos and our alpha is less than our alpha of 0.5, we reject the whole. And there is minor evidence that the saturated fat of Domino's is greater than Papa John's. And using this and the sample interval, we can conclude the following: that we are 90% confident that the 2 change are different.